Hello. Just want to make a video about a quote unquote game engine I'm making. I don't really know what you'd call it per se, but I'm calling it a game engine, but it's just a collection of tools to help you make a game. So I'm just going to call it that. But so the program is written in C, but you make the games with Lua. Whether or not you're actually making games is, up to you. But you basically use the Lua script to make the quote unquote game that you wanna make. So you start by initialize. So everything is in this Nyquist table, NYQ. And if I initialize it, so I can like initialize the window, I can name the name of the window. Then I can figure out where on the window I want it to be. So I can say 200 X and Y values. Doesn't really matter. Then the width of the window. And then the scale. So this scale actually, so it'll take the width and the height and how do I say this correctly? So if your width is 200 by 200, but then you scale it up by 2, it's going to be twice as big, but all the pixels are still going to be within that same 200 by 200 grid, if that makes any sense. So that's how you initialize the window. And then I have to update it, update. And then we could delay for like one second, right? Oh, don't need a comma in Lua. So if I want to run this script, that's the name of the program. And then I just, do the path to the script, then run it. Just makes a window for 1 second and then it closes. Not very interesting, but there's a lot of other things we can do with this. So if I want to write some text to the screen, I can do that too. So I could do Nyquist.text.init, and then I can do the type of TTF file I want to use. So everything in this engine uses things from the .res folder. In this case, it's right here. So our fonts, this is a collection of fonts that we have. So I can use the Nodo, whatever, Nodo sans mono regular .tf font. And I'm going to say I want it to be 20. So now I have my font. If I want to, draw it to the screen, first I actually have to, so that's just initializing it, saying, hey, I want to use this font with this font size. Now if I want to create a font, and what do I want to say? I want to say hello. And then the position, so X equals, I don't know, let's say in the middle of the screen. So I can't get 100% in the middle of the screen, so because I don't know the width of the item, so I'm just going to say somewhat close. And then we're going to have RGB values for the foreground color. RGB A, actually. All right, cool. And then I'm just going to like put it on like separate lines like this just to make it a little more pleasing to look at. And then for the background, I'm just going to make that all white or black. So I created it, but that doesn't mean much. And when I create it, it'll give me an ID that I can use to update. So, whoops. So I can do, text ID equals. Now I can use that to update my text. And let's actually take this. No, hang on. Let's just show you what's going to happen to update. So I need the text ID, but I also need the position of where I want to update it. So I can rewrite the same thing, but I mean, obviously I don't have to, which I'll show you later why I don't have to. So if I run this, it just writes hello to the screen, and I can make the font a little bit bigger so it might be a little bit easier to read. So yeah, nothing too crazy there. But if I don't want to keep writing the X and Y value, I can put it on a separate line, text position. I do text position. There we go. So yep, it does the same thing. And instead of, let's make it all the way at the top. Yep, top left. Yep, so that we just created some text at the top left. Now, you can also get events too. So if you want to do that, we're probably gonna have to mess with loops a little bit. So an easy way to get events is how you get events with the Nyquist engine, Nyquist 2D engine. You do Nyq.events.init, right? And it's going to return a key press. And later, I'll explain that a little bit later on what that is. But we need a table. So what this table is it's a list of key value pairs. So the key would be basically what you're defining as the name for the key. So if you want the key W to mean move north, then you could put the key as move north, and then the value is W, right? But if you wanted, like, I don't know, enter to be start, you could put the key as start and then the value as enter. So yeah, for example, so I could do move, like I was saying earlier, move north, and I could make it W. So I'm not just pulling these keyboard. So this is the name for the key on the keyboard, but this isn't coming from anywhere. Actually, this is coming from STL key codes. It's coming from here. So these key names right here in STL, that's where these names are actually coming from for the key I'm hitting on the keyboard. So let's do move north. Let's do east. Let's have east be D, WASD, you know. And then south, S. Oh, didn't spell that right. And then west as A. So you just have your like standard WASD keys that you see in most games. And basically what this returns is a list of these keys that you made, right? So it'll be a list of all the keys, and it'll return, and they'll be true or false depending on whether you've hit them on the keyboard, whether they're pressed down on the keyboard. I'm sorry. So if move north, which is an alias for the W key, is hit, then move north will be true in the key press table. So do an example of that. So now we can get rid of this delay. We're not going to need that anymore. So I can do Nyq.quit. And what Nyq.quit is whenever you close out of the window, Nyq.quit will be false. Otherwise, it's just always true. And we're still going to delay it a little bit by 10 milliseconds. So this delay is in milliseconds, by the way, if I didn't say before. And we could go ahead and say something like if key press dot move north, right? So if the key pressed due north is pressed down, then print move north. All right, let's see what happens. I have to update the screen too, which doesn't take any parameters, so it should be fine like that. It does close right away, as you've just seen. So I have to do that. Oh, I'm sorry. Nyquist will be true if you Nyquist will be true when you close the window. That obviously. So and then otherwise it just always falls. So I have to put not here. That's why it closes right away. Okay. So when I hit the W key, it should say move north. But let's see if I can figure out what's going on here. I do need to update the key presses. So that is something I do need to do. That's why I couldn't close out of the window normally. If you don't update the key presses, then Nyquist won't be updated either. So that's a good thing to just kind of acknowledge right there. So that's something I should have done. So let's go back to the events. So Nyquist.events update, and then I have to update the key presses. Now I believe I should be good. Oh, I didn't spell update. There we go. So now I can close out of the window like normal. And if I press W, it says we move north. Cool. So I'm still learning my own little engine. And, I make mistakes too in my own code. Everyone does. So let's get a little more complicated with this. So you notice how we can update the text right here? And we can use the text position, right? So let's update the text right over here. But what we'll do is say text position dot x or y minus equals text position dot y minus 1. So we're going to decrease the y value of the text position every time we go north. Or hit the north key, move north key. So we're moving up. That's cool. But now we want to probably move down, right? So we can copy this, use an else if statement. And instead of moving north, let's move south. And let's add one so we can go down. So now when I hit the... Not quite. So move south. Right. So let's see. Did I do something wrong? Oh, right. This doesn't follow this convention of key names. This has to be a capital S. So now if I press S, I can move south. And when I press W, I can move north. Now let's just try all of the cardinal directions, since we already started doing the cardinal directions. So let's try east. So that'd be x plus 1. And let's also do west, which should just be minus 1. So now I should be able to move the text. Well, I should be able to move the text in every cardinal direction unless I did something wrong. D, north, east, southwest. I'm thinking that I have to subtract Did I put X? Oh, that's why. I'm updating the X value and not, the Y value, not the X. There we go. Now I can move in every cardinal direction. And I can move that text in any cardinal direction. So pretty simple functionality right there. So now, obviously this isn't what you would always want to do. What if you wanted to add images of some sort? Well, you can do that too. And like I said, all your resources that you're going to use for any game is going to be on the .res folder, and it'll be in the local directory of wherever you are making the game at. And it'll and the program, the Nyquist 2D engine will automatically create that folder for you, so you don't have to worry about making it. But you do have to add your own TTF files, your own PNG files, and whatever else you want to add. And you have to add them to the right directory within the .res directory. So for this, we have a directory of images. We have data, fonts, images, and it looks like this is being a little difficult with me. It's not showing anything that's in there. See, there we go. Okay, well, this does show everything that's in the .res directory. So we have a C++.png image. So let's see if we can get that loaded using this engine. So there's a really easy thing to do to create images, and it's not too different from what we just did for events, to be with text, to be honest. So we can also add a image position, and we'll just add it x equals 200, y equals 200. So that's the position that we want our image in. And then we can create the image with, we have to initialize creating image, initialize using images first with image.init. Then we can create our images that we want to use for the game right here. So we want to use the C++.png file. That's so weird. I've never had a Nerdtree do that for me. Do that to me. It literally will not show any of the files in any of the directories. Oh, let's see if I can just open that file back up and maybe yeah, there we go. Now it's actually showing it. Yeah, so now we can actually look at all the files in there. So we want to use the C++ PNG, and then we're going to use the image position that we just set up, and we can set the width to whatever we want. It'll because it's using a render, the SDL render. We can just set the width and the height to whatever we want, and then I'm just going to set it to 100 by 100. So now that we create our image, it's going to also return image ID, kind of like our font, and we update it in a pretty similar way. So in order to update the image, we're going to do Nyq.image.update, and we're going to do image ID, image ID, and then image position. So it should draw an image. Yep, right there, right where we set it to draw. So we can also move the image if we wanted to. Let's copy the controls from earlier, but instead of having text position, let's make it say image position. So now when I hit the WASD keys, it'll move the image. Obviously, you notice something happening here. And it's not redrawing the background. That's why you get this weird smudge as I move the image. And if I wanted to redraw the background, I can do that with Nyquist.graphics. So if I go Nyquist.graphics and I set a color first. So let's set the color to the RGB value of black. And then we're going to do a clear, which just sets the whole screen to the set color that you just set. So now every time I move, it just fills the whole background, the whole render with black. So you don't get that smudging anymore. So that's a really simple example. You can also use databases, which is something I've just been working on. So when I use a database, I usually do something called database normalization. And I like to use a lot of foreign keys to other tables. So I kind of kept that in mind as I made the database part of the engine. Don't know if a lot of people will be familiar with it, but it uses SQL. But it's a higher level version of it. It's very what is the word for it? It's a higher level of abstraction, basically. So let's say we wanted to add a schema. First, we can add our schema, and a schema is just going to be a table. And let's add, I don't know, some items. Right? And I'm going to say the type for the item is a db integer. And when you so basically what I'm doing here is I'm setting a schema. A schema is like a collection of tables in SQL. They're different from the tables in Lua. I mean, even though this is a table, but just follow along with what I'm saying. It might make more sense. So this is going to be the name of the SQL table items, right? This is going to be the name of the column in the table, and this is going to be the type of data that column is going to take. So I'm saying I have a type, and I'm going to also have a weight for the item. Whoops. Which is also going to be a db integer. And I'm going to have a name for the item, which is going to be text. So in order to actually create these tables, we have to initialize the database, like we've been initializing everything else. And, you know, for this example, I'm writing everything into one file. I would be assuming that you would be using, require statements to make modules so that this isn't all bunched up in one file, or at least be a bit neater than what I'm doing now. But for this, I think it's okay that I'm putting it all in one file just to show, what you can do with the engine. So I can init, and I'm going to init this file right here in .res. So it looks for the root of .res, which it looks for a database file in the root anyways. So I'm going to use test.db. And if that file doesn't exist, right now you'll have to make it. But in the future, I'm going to make it to where it kind of creates the file for you, so you don't have to just make it. I think it has to do with how I'm opening up the SQLite database. But anyways, let's just initialize it. Don't need a comma there. So I'll show you what this initialize does. So I'm going to run. So first, actually, I'm going to remove. I'm going to remove that database. I'm actually going to add it back. I'm doing this because I'm going to try to remove all of the tables and anything else that was. I'm just removing all the tables that were there so that it can make these tables new again. So boom. I'm running the game like usual, and you'll see that it said it just showed create items, and it just made a table for me. So I can actually look at what it just did. So I can do SQLite 3 res and look at that. And I'm going to actually look at the schema. And you see that it did just add the item schema that we just put in there. And you'll see it automatically adds an ID, which is just by default, it adds that. And it adds the type like we added, which is an integer, name, like we said before, and the weight, which is also an integer. So yeah, that worked pretty well. Now, what if we want to insert data into the schema? Well, we can do that too. So I can do Nyquist.insert database, insert, and where do we want to insert it to? What table do we want to insert to? Well, we want to insert to the items table. And so what do we want to, well, we want to do the key value pairs. So the items has type, weight, and name. So we want to set those values to their appropriate type. So that's an integer. So we want to make the type an integer. So let's say 2. So then we need weight. So what do we want the weight to be? Let's say, well, I don't know, 100. And the name to be pillow. Pillow is probably not going to be, if we're doing by pounds, that'd probably not be 100. Let's do like 3. So yeah, let's see what happens. Oh, and it sees, we can see here that it said it failed to fetch. Let's see why that is. Did I spell something wrong? Yeah, it looks like I spelt this wrong. There we go. So now it should work. Integer, text. That should be right. Failed to fetch data. 2 values for 3 columns. Well, let's see. Let's look at it again. I just deleted it and re-added it. So select star from items. All right, so it did add it. I think what happened was because so what this does, I do know what happened. I spelt this wrong the first time, right? So initialize creates the schema, right? It creates the tables that are in the schema. But if this table name already exists within the SQLite database, it's not going to recreate that table. Initialize won't recreate it if it already exists. And what was happening is because it already exists, it already had the name weight wrong. So every time I tried to call this, it wouldn't insert because the weight was spelled wrong. So yeah. What you can also do is so you don't keep adding the same data. So I can do this again, and it'll actually insert the same data, right? Watch. So if I go here, watch. It just added pillows twice. What if I don't want to add the same data twice? Well, if I do unique after this, I can prevent that. So now, if I called this insert twice, it won't let me add it the second time. So if I run this program twice, it'll actually fail the second time. So I can show you that. But I have to remove the database first. So remove the database, add the database file again, then run it. First time, it's gonna be fine. Boom, added it. But if I tried to run it the second time, cannot create the table. That's because we added that constraint of unique. So that doesn't mean that I can actually have the same thing, but one of the values be different, and it'll add it fine. It's just saying that all three of these values, or every value that's unique, if all three of these uniques are exactly the same as another element in the as another table element, then it's not going to add it. But if just one element of these uniques is different, then it doesn't matter. It'll still add it. So I just changed the type from 2 to 1, and now it'll add. And if I'll show you right here, boom. So the only thing we changed was the type, as you can see. It's 1 instead of 2. Along with that, you can also use foreign keys, like I was saying before. So let's add like inventory. But we gotta have a comma after that. So inventory, we could do item ID, items. So what this is saying right here, this item ID is just referring to basically the ID of an element in the items. An element in one of the what do you call something that's inserted into a database? I'm not sure. Columns. In one of the columns in the items table. Rows. Rows? Yeah, that has to be right. Rows. So it's just saying that it's going to use one of the IDs from one of the rows in the items. And it has to be one of the IDs in the items table. In the rows of items. Yeah, one of the IDs in the rows of items. It has to be one of the IDs for the rows of items. That sounds right. I have to say it back to like make sure I'm saying it right. So we can also add a person ID, and it could be a reference foreign key to people, and we can add that people table. And let's say we have a name for each person. And we also have an age. No, not age, integer. We don't care if it's unique because a lot of people have the same age and name. All right, so now this is going to kind of change how we just added our data. And it won't actually, if I run this, it won't create this items table because it already exists, but it will create these two tables. So when I run this, so right now with schema, we only have that one items table in, which is pretty big. And this sequence, which is always exists. So let's run it. And we can see that from the text down below that it looks like it ran some SQL to create those tables. You can see that we have two more tables, like we should, the people and the inventory. So let's try to add to the inventory, and I can show you real quick that. See, with the inventory, it says person ID and it references people. So it's a foreign key item ID, and then that's an int that references items. So we do have foreign keys in here. So yeah, let's insert into inventory. And like I said before, when we insert something in inventory, it has to be a person and item that already exists. So if I try to, I'll show you an example that will automatically fail. So we don't even have people yet. So we can't add a person ID. We can't even insert into inventory until we've created a row into the people table, a row from the people table. We don't have a row inserted into people. So let's, I'll just show you that. So an item ID, we do have an item. We have, it'll have the ID of 1. So each row in each table has an ID that's automatically created, that's auto increment. So every time you created a new element in the table, it auto increments the ID. So this will fail. I'll just show you that it'll fail. Yep. Key constraint failed. But if I make an item, it will not fail. So Nyquist.database.insert to items, and let's insert a type. Doesn't matter. Oh no, I'm sorry, a person. We already have an item. So into people, insert into people, name, Joe, and then age 55. Why not? So now, since we're adding, someone into the people table, now this person table, the person ID should exist of 1 because, it's going to auto increment and automatically have a value of 1. So let's see what happens there. Yep. And if we select from people, we'll see that we have 1 person, Joe. And then if we select from, what was it? Inventory. You see that we do have 1 item, which is the item ID 1, and the person ID 1, which is Joe, person, because he has that ID, and then item ID, which I don't know why it's doing that. Item ID 1, which is this, which is this right here. A pillow of type 2, which is what this person is carrying, I guess. So, yeah. That's just a little bit of how this quote-unquote engine works. I think I just showed off everything that I've been working on. But yeah, I'm trying to make it as high level as I can, right? But also make it, more detailed when you need to be more detailed. So, for me, I can obviously go back into the source code and change it if I wanted to. So that's really nice. Like, that's why Lua is just super helpful all in all in general. Like, how much code I wrote to make this work compared to how much code it just, it takes just to write the script to create a game is like the script code is like so minimal compared to, how much code I wrote to get the script to work well. So yeah, I just like the fact that you can have a high level abstraction, and then you can have a really low level abstraction, and you understand what's happening behind the scenes at the exact same time. But yeah, hopefully, I might put up the website for this. I might not. I'm still working on it, so if I don't, it's probably just because I want to have more of it finished. But yeah, hopefully you guys enjoyed, and hopefully more people get to experiment with it in the future. Experiment with that engine, with this engine, I don't know. English is weird. All right, bye.